Hi everybody and welcome. Today we're going to be talking about proportions and solving proportion questions. So your goal after watching this video should be able to fluently calculate and solve proportion questions with unknowns. So to start off, always applying it to the real world, so I figured I would let my drawings take the back seat and let Da Vinci take the front seat here. So we're going to take a look at the Mona Lisa. So why is the Mona Lisa such a famous painting, and what are some aspects of it that make it so special? So one of the things here, you may or may not have heard of it, the golden ratio is what they call it. And it's kind of this idea using the Fibonacci sequence to form more or less an aesthetically pleasing pattern. So first, if you don't know what the Fibonacci sequence is, you don't obviously need it to know how to solve proportions, but if you ever just wanted to know about Da Vinci and the Mona Lisa and any of those things, it's good trivial knowledge to have. So Fibonacci sequence goes like this, and maybe I should do it in a slightly thicker pen here. So it goes 1, 1, 2, 3, 5, and so on. So basically you take two numbers, add them together, and it gives you the next number. So 1 plus 1 is 2. And then you take 1 and 2, add that together to get 3. 2 and 3 get you 5, and it keeps repeating like that. So the next number would be 8, go on to 13, so on and so forth. So how does this apply, though, to what we're looking at here? So you can basically make a bunch of triangles or spirals, but we can kind of see these more as triangles here I guess this would be the closest way to kind of define it, more or less like that. So we can see those as a function of area, and actually the proportion of the area that those triangles take up relative to the space gets us to our golden proportion. And it's actually created using the Fibonacci sequence. So right here, this first one is 1, 1. This area is double that, it's 2. This one goes up to 3. This one would be 5. It would keep going on to 8 for the next sequence, and then the big box on the bottom would be 13. So that is kind of how it's calculated by hand, and you could go through and see that. But kind of the big point of emphasis here is it's a proportion that shows us basically where to place our next line, our next fitting. And we can see that in Mona Lisa's face. You can usually see it in, I think roses are a natural example, kind of like how their flowers go out. But overall, it's an example of a proportion. So let's keep going, and let's actually define what is a proportion. So what are we talking about here? So proportion this is when you have two varying quantities with a constant ratio. So what this means for us is, like we were talking about in the last video, miles per hour. If you're going 2 miles per 1 hour, to keep that ratio constant, we'd also go 4 miles, except this time over 2 hours. So if we divide both of these, we'll get 2. Maybe we're going really far and we're going 100 miles. Well, if we're keeping that same ratio and we have to divide our answer to get 2, that means we'd have to have 50 hours on the bottom. So it's a level of constancy there. Basically, if you divide it, you'll get the same answer back to that same unit rate here that we started off with. So that's the idea for proportions. So how we're going to apply that today, and how we're going to see this come up the most frequently in math class, is actually going through and evaluating and solving some of these questions. So we are trying to solve for our constant, and when we solve for that constant, just like we did with the miles per hour question, we want to make sure that it's the same thing. So 10 divided by 8, we want that to be the same answer as whatever we solve for n divided by 10. So the easiest way to do this and the most clear is to cross multiply. So what that means is we take the diagonals, we multiply them together, and we set them equal to each other. So on one side, we'll have 10 times 10, and on the other side, we'll have 8 times n. And let's highlight this in 2 different colors so we can see what goes where. So we have 8 times n there, and then our other diagonal, we have 10 times 10 there. So now we can go through and solve. We'll get 100 on the left, 8n on the right side, divide both sides by 8, and we'll get to that answer of n equals, and let's get our full decimal for this one, that way we can for sure calculate. So 100 divided by 8 gets us to an answer of 12.5. So let's double check here. So if we divide 10 by 8, we get an answer of 1.25. If we divide 12.5 by 10, that also gets us to an answer of 1.25. So we kept our proportion constant. That's why we know that our n value does have to be 12.5. So a slightly more challenging question, we'll do the setup for number 6. So again, if we are cross multiplying here, so we'll underline these two and we'll put a circle around these two, we'll be left with 10 times b plus 5 equals 7 times 5, or 35. The trick to this one is just being careful to distribute, or you can divide if you'd prefer. So instead of just having 10 times b, it's also 10b plus 10 times 5 as well, or plus 50. So be careful solving these, but the biggest idea for this, again, today is cross multiplication, making sure that ratio is constant, and then we'll be able to solve for the variable that we're looking for. Awesome, so that is cross multiplying with proportions and solving for unknowns with proportions. If you have any questions, as always, definitely let me know. That's today's video. Thanks for tuning in.